Hi, hello dear students, welcome to our channel Maths with Panindra. This is Students' Choice and Voice. This is the tagline of my channel. Let us have a discussion in this session limits and continuity problems. First question, if f of x equal to x power 1 by x minus 1 for x is not equal to 1 and f is continuous at x is equal to 1, then f of n equal to options. First option e, second option e power minus 1, third option e power minus 2, fourth option e power 2. So first f of x is continuous at x is equal to 1. F of x is continuous at x is equal to 1. Then f of 1 is equal to limit x tends to 1 f of x. So in place of f of x, substitute the given function limit x tends to 1 x power 1 by x minus 1. So x is equal to 1, if we substitute, it will reach us to 1 power infinity. We know that whenever the given function or given limit it reaches to 1 power infinity, we have some formula which we already discussed, and a number of problems we discussed based on that. Limit x tends to a f of x whole power g of x is equal to 1 power infinity, then limit can be written as e power limit x tends to a g of x into f of x minus 1. This is the way you can apply. So by using this procedure, this limit will becomes e power limit x tends to 1 1 by x minus 1 g of x into f of x minus 1. So e power limit x tends to 1 x minus 1 by x minus 1. So e power limit of x tends to 1 to constant 1 is constant, so it will become e. So e is the right option which is there in the first option. I hope everyone understand. We'll move to the next question. If f of x equal to one minus root 2 sin x divided by pi minus 4x, if x is not equal to pi by 4, a if x is equal to pi by 4 is continuous at x is equal to pi by 4, then a is equal to options 4 2 1 1 by 4. So this is the given function. So clearly it is there, f of x is continuous. F of x is continuous at x is equal to pi by 4. F of x is continuous at x is equal to pi by 4. Then f of pi by 4 is equal to limit x tends to pi by 4 f of x. So which is equal to limit x tends to pi by 4. F of x value is 1 minus root 2 sin x by pi minus 4x. X is equal to pi by 4, if you substitute directly, it will becomes indeterminate form. So by using LHospital rule, LH rule, limit x tends to pi by 4, constant 1 derivative 0 minus root 2 into sin x derivative is cos x divided by pi constant derivative 0 minus 4x derivative is minus 4. Minus 4 into x derivative is 1. So here x is equal to pi by 4, if we substitute, minus root 2 into cos pi by 4 by minus 4. Here minus get cancelled. Root 2 into cos pi by 4 is also root 2 by 4. Root 2 get cancelled, 1 by 4. So therefore they are asking a value, f of pi by 4. When x is equal to pi by 4, the function value is equal to a. That means when x is equal to pi by 4, function value f of x as a. Therefore f of pi by 4, which is equal to a, which is equal to 1 by 4. So 1 by 4 is there in the fourth option. We will move to the another question. The discontinuous points of f of x is equal to 1 by log mod x or options 0 comma plus or minus 2, 1 comma plus or minus 2, 0 comma plus or minus 1, 0 comma plus or minus 3. See here f of x is equal to 1 by log mod x. 1 by f of x form is there. 1 by f of x, when it will be defined? 1 by log mod x is defined when the denominator should not be equal to 0. When log mod x is defined when mod x should not be equal to 0. That too, logarithms, mod x is not equal to 0 and mod x should not be equal to 1 also. Why? Because x is equal to 0 means log 0 we cannot define. Log 0 undefined, we don't know. So x is not equal to 0 means x is equal to, at x is equal to 0, x is not equal to 1 means mod x is not equal to 1. That implies that x is equal to plus or minus 1. Except these points, x is equal to 0 and plus or minus 1, the function is continuous. So, therefore, the function f of x is discontinuous at 0 comma plus or minus 1. Otherwise, except these points, the function is continuous. This is the meaning. So, the function f of x is discontinuous at x is equal to 0 and plus or minus 1, which is there in the third option, dear students. I hope everyone understand that. Thank you, dear students, for watching my channel.